G'day comrade subscribers. So I'm just doing a bit of refurbishment work on the Sirius. It's interesting, the design of these kind of, there's only, alright, so that's where okay, I can put some rubber feet in there, that's no problem. But it's weird how they kind of make, oh okay, no, we missed and we, a bit strange. Anyway, so what I've done is I've drilled a new hole for the 2.1mm power socket, put it where the power is. So I'll solder that up, push it in, and then solder onto the board. I think I might, for the tape, I think I might just put in a 3.5mm socket. I'll rewire this one up as well, the DIN as well, but I just really need the input there. Good old reset button. Yeah, I've scrubbed everything, so I've given as much as I can. So everything's clean. I've also pulled apart the keyboard, washed all the keys, scrubbed the keys, and also the top case. So it's a bit cleaner now. Start putting it back together. Like I said, case is scrubbed, although it could be better, but keycaps are all washed and scrubbed. Actually a bit of dirt on them, had to scrub them. This was a bit stuck, so it was a bit wider, so I've had to sand the top and bottom of the key down a bit, but now it's quite good. So I'm just adding the stick better, just adding the rubber feet that were kind of missing. Well, they didn't ever have rubber feet, so I'm just going through my rubber feet collection, and I'm just going to try these ones out. They fit. Just going to make sure that they stick properly. They fit perfectly in there. Okay. Now, as you can probably see, I found where I've hid my grommets. I was looking for grommets before. So now I know where they are. Right, you can see I've got some brand new screws in there. So that is, which way did the keyboard go? Bloody keyboard. That holds the case in. So it was weird. So they've got these holes here which are empty, and there was like a little bit of wire. Probably, I don't know if you remember seeing it in part 1 video. Just kind of embedded in the case, coming up through, and that looks to be how they were securing the board in. Absolutely bizarre. So I've removed that, and I've just put in some 3mm screws. So I've got it 3 points, and now it's nice and hard. So new DC input there, 2.1mm socket, straight onto the board. I was thinking of maybe adding a switch, but won't worry about it. I'll replace the DINs. I'm not too worried about joystick at the moment. I don't really use it. But I'll put in a new 3-pin DIN and a new, because this needs sound as well, RGBS ground. I think it's using the sheath. I think it's using the outside as one of the conductors. So 5-pin isn't enough for audio because I don't have any 3.5mm sockets, panel mount sockets, mono. So I was actually, what should I do? Actually, I might add in a 3.5mm socket just for audio. That way I can just plug in my little amplified speaker, powered speaker. So I'll use that for audio, and then I'll just use a 5-pin DIN for RGBS and ground. I won't put sound on that one. And then a 3-pin DIN for cassette, and see if I've broken it. But yeah, see if we can load something. So that's all back together. So keyboard, yeah, we'll see how the keyboard. I've gone over the circuit board with IPA. That's unfortunate. I don't have any deoxide or anything like that, so I've used IPA. That's the best I had. So we'll see that if that improves it. Oh yeah, I've got to reconnect the reset switch. So, getting there. Good evening. So yeah, just continuing. I'm not going to get much more done tonight because I realised, because I thought I might just, problem with the keyboard, it's attached. I don't actually have any panel mount 5-pin DIN sockets, so I'm going to have to pop out to JCar tomorrow to get them. I know I could reuse these, but I thought I'll just put in new ones. So in the meantime, I am actually just tracing the RGB signals from the ULA via this 74LS295 register equivalent. It's I think it's a K555IR16. So they go underneath the CPU up to here, into here. Then we've got some resistors and we've got some diodes to ground, I think. So then these resistors are connected up to these 3 resistors here, which are then connected up to the pins there. So output, storage register, I guess. What is it? So yeah, storage register 295. It's also can be used as a serial to parallel, parallel to serial converter, but I don't think it's being used for that. I just think it's being used kind of like as a buffer. Resistor, diodes to ground, some more resistors, and then out. So this is the ULA pinout. Thanks to the ever reliable zxbyte.ru. Actually, I think he's Belarusian. I've spoken to him on Telegram. So you can see here RGB are on pin 10, 11, 12, and we've got 18 for a composite signal, and then sync on pin 43 of our little ULA. So that's the pin 10, 11, 12. So like I said, they go across up to here to the input to this K555IR16 or 74LS295, and then the outputs go to these resistors here, and then I think these are diodes which are all connected to ground, I think, but these resistors here are connected to these resistors here, and then these resistors here are connected to the video output there. So I think I've figured out, so I think I figured out blue and red. So blue and red, and I think that was sync. I'm pretty sure that was sync. That was what I decided was sync anyway. So now just blue, red, and what's the other one? Green. So I just need to confirm green. So I think I might have had the colours wrong last night. I think I definitely had that as green. So it's definitely red according to the tracing I've done. So green goes to pin 4, which is the C input. So it's the C input on here, and which you can't see. So it's the C input on here, which is pin 4, and the output QC is pin 11. Let's just get my, so it's pin 11. So was it? Yep, so 14, 13, 12, 11. That one there. Is that one there, is it? Yep. Which goes to there. Yeah, that makes sense. So that one there goes to that resistor up there, and then that resistor up there jumps up to that one there. So that's green. Blue, red, green. That must be sync. I don't know if there is composite out. So composite. So pin 18 is actually connected to here as well. So pin 18 Y signal is connected to pin 5, which is the D, and then QD is pin 10, which I guess is that one there. So I'm not sure where that goes. That should go somewhere. I don't know if it's, anyway, I'm not going to worry about composite. Anyway, so there we go. So yeah, and then once I get it all wired up, I'll definitely try out the border command as suggested. Make sure the colours look right. So pretty simple. I think I've tried tracing this on other machines with this type of ULA, and it's been overly complicated because I don't have a pinout for the socket. So this is quite simple. I'm quite impressed by this board actually. It's quite nice. Okay, but yeah, continue tomorrow. Oh, right, let's continue. So I've got some new sockets, and I've replaced the RGB with a new one, 5-pin DIN. So, and I've added a speaker output, 3.5mm mono there, like that. As you can see, I've got the color-coded cables, so I'm pretty sure that should be correct after following through everything. And then I'm pretty sure that should be the audio out, because I think that was originally connected to the TV DIN socket. And I realized I made a mistake with the DC input. I mistakenly bought 2.5mm DC sockets instead of 2.1, and I keep using them and I keep forgetting that I bought them. So all my 2.1mm plugs won't fit this because it's 2.5. So I'm going to ignore this for now. I'm going to replace it with, get some 2.1mm. Anyway, so I replaced these two. Let's just see, well, if it still works. Keyboard's also been fully refurbished and cleaned. So let's see if that works a bit better. Looks like one of my rubber feet have come off already. So I might need to, I don't know, give that a clean with some IPA just to make sure it sticks a bit better. Oh, yeah, of course I need to make up a RGB cable, don't I? So I made a pretty simple pin out, 5-pin DIN. I've just gone RG, ground is always pin 2, so RGBS. So red on pin 1, green on pin 4, ground on pin 2, blue on pin 5, and sync on pin 3. So I just need to make up a little cable with a 5-pin DIN plug, and then we'll be able to test it. Then we'll go on and sort out the audio, well, the cassette input. Not too worried about cassette output, but the cassette input, so we can load something, try and load something anyway. Okay, cable's made up. I've plugged in an amplified speaker. I've powered on. Start recording. Image doesn't look too good considering it's RGB. But let's see. Alright. Press enter. Okay, so let's try the different colours. So border, blue. Okay, we got a blue. Border red. Okay, got a red. Border magenta. Okay, looks like I've got the pinout correct. Border green. It's just the image is pretty shit, if you ask me. Cyan. Okay, border yellow. And this is what white looks like. Back to white. What about black? Border 0. There we go. Keyboard's okay. Like I said, I've given it a bit of a clean. No. Where's inverted? Where's John? I do actually have some Spectrum stickers that you can stick on keys, because some of these are a bit worn, and I think, like, I'm just there's cap shift. What's this key? Oh, maybe I'm supposed to press that. There we go. That's what it was. Print, test, space. That's it. All right. And then semicolon. No. Really press that one. Where's semicolon? No, that's a plus. Oops. Okay, I didn't mean to do that, but anyway. All right, run. Okay. Of course. 20. So keyboard seems to be working. Okay. Okay, so list. No, I meant to do list. List is K. Okay. So what if I go? Yeah. Anyway. Okay, so that's kind of working now. Like I said, I still need to do the power. I thought that was speaker because I thought that's where we were getting. That's where we're getting pulses come out. Let's just check the oscilloscope. Let's stop recording there. Alright, I just want to check the oscilloscope, what happens when I press a key on that point there. Alright, so I'm not doing anything at the moment. So that's what I get when I press a key. So I would have thought that should be generating. So it's generating what, 5 volt, or just over 4 volts. I want to change the trigger point back to there. Nice square wave, but it's not. I wasn't getting any audio out. Why wasn't I not getting any audio out? Why can I not hear that? Okay, well I definitely think that's the audio out. I'm just not hearing anything out of my speaker. Alright, something to look at later. I guess I'll sort out the cassette input and the cassette output. I'm not sure which is which yet. Let's have a look. So that's one of the cassette ports, either input or output, and one of the others was up here, I think somewhere, maybe up there. So I'm not too worried about the output, it's more the input that I want to get. So I think actually, let's have a look at the actual schematic. This is the schematic of the Spectrum. And you can see here on the ULA we've got cassette and speaker. So come out here now for there's the speaker output, so transistor amplifier. I don't see any transistors on here. Anyway, whatever, we'll worry about that later. So mic, that's recording, and ear, I think ear, that's playback in, isn't it? So it actually goes in through a resistor. So this could be mic then connecting straight into a capacitor. That could be the out. So basically the output. So I want this other one to be the input, I guess. Go through a capacitor to, I guess, cut out the DC. Yeah, all right. I'll have a look at the photos I took, and I'll try that for loading software. G'day again. So, I've been going around in circles. I think I've just established that this point here is the tape output. So I've managed to trace it back. So it goes down to here, to this point here, and then this point here goes to this capacitor. We've got a pair of resistors, and then what we've got here is KR 1533 LP, I wrote it down 5, I think. So that is an equivalent LP5. equivalent to a 74LS86, which is a quad 2-input XOR. And so I think I've traced one of the outputs back down to here. This point here, somewhere here, 1, 2. Well, this is tape output, isn't it? So that's one of the inputs. Yep. And this goes back to the BMK, pin 13. What's that? 10, 11, 12, 13. So pin 13 on the BMK. And pin 13 is TO, so tape output. And you've got sound output on 15. So I'm looking for tape input on pin 19, which is this line here. This line here. So that goes into this KR1533, what was it, LN1, which is a 74LS04 equivalent, which is a hex inverter. Yeah, so this is where the other wire was connected to. So we had a wire connected here. So that we had, this is the tape here. So we had a wire connected here going up to the tape, and then we had a wire here as well. That was loose. So I didn't know which was which. So this is definitely output because it goes back to the TO. But this little mess down here, I'm completely confused by, because from what I can tell, it's pretty simple, right? Hex inverters. So this is the Soviet data sheet here. So they have diagrams like this. So you can see that we've got inputs on 1, 3, 5, 9, 11, and 13, and then 2, 4, 6, 8, 10, and 12 are the outputs there. You can see the diagram there. But certainly looking at the underside as well, which I'll show a picture of. So if we've got tape in is coming along this line here, which is then broken, and then this flimsy little wire comes over here. So that's pin 7 there. Yep, 7, which is ground. Pin 8, pin 9, pin 10. So pin 10 is an inverter output. So the output's coming there to the BMK. So far so good. But then when I look at, I wrote it down just before. Let me just buzz this out again, because on the underside is where it gets a bit confusing. So the input for 10 is pin 11, which is that one there. What else is pin 11 connect? So I want to try and find out. The pin 11 is connected to pin 13, which is an input, which is also, this is where I'm getting confused. So an input's connected to an input, so, but also, so pin 10, so the input for pin 10, right, sorry, it was pin 11, wasn't it? That's what I was talking about. Which was that one there? Which is then, sorry, which you can't see, which is connected to pin 8. Alright, which is an output of pin 9. So we've got two inverters. Okay, alright, maybe I'm making sense now. Okay, and because they're also connected underneath as well. Yeah, which is connected to ground. Okay, that's what I'm getting confused by. So pin 9 is grounded. So pin 9 is the input for pin 8, which is that one there. Pin 9 is the input for pin 8. So that's always going to be high then. Alright, hang on. So this is where I'm getting confused again. So it's not difficult, is it? Alright, let me figure this out again.
I'm getting confused. So, what I can tell, so pin 10 goes off to the BMK tape in, right? Fair enough, easy enough. And it comes from pin 8. So pin 8, which is over here, which is an output, is connected to pin 11, pin 13. The problem is pin 8 is connected to ground. Well, it's connected, it's connected, oh no, the input of pin 9, of pin 8, so pin 9 is connected across to the output of pin 6, which is also connected to ground. So the tape in is always grounded. So pin 8, pin 9 is the input to pin 8, so that's pin 8. Pin 8 goes into pin 11, which then goes, and then which is inverted, and pin 10 goes off to the BMK. But the input to pin 8, pin 9, is grounded. Now how the fuck is this supposed to work? So the input was connected to here. So there was another wire connected to here. And then, so this capacitor here then goes towards this trinary of resistors, which are then connected to, pin 1 and pin 2. So pin 1 is an input and pin 2 is the inverted output. But how does that relate to the tape in, which is on pin 10? So the output of the capacitor, some of this is a bit dodgy because it hasn't really been registering the continuity. Come on, man. All right, let me just double check. Try and get a continuity check here, because I can see it is connected. Oh, did I just get something then? But anyway, so pin 2. So pin 2 is an output. I'll put a picture up of what I'm trying to, of the underside. So I don't understand. Especially if we trace it back to the BMK. Pin 10 input is pin 11, and which is then connected to pin 8, which is grounded. So that's, I wasn't getting anything on either one. So I don't understand how this worked, unless someone's been futzing around with it and they've connected the wire to the wrong place. But still, I don't understand why pin 8 is grounded. And I'll give you a closer look, but I'll also put up the picture as well. Hopefully it helps. So, what have we got? So like I said, so this is the tape input to the BMK, which you can see is connected via this tiny little wire to pin 10. So 8, 9, 10. Now the input for pin 10 is pin 11, which is this next one up. And this pin 11 is connected to pin 8 and pin 13. And they're both connected to ground. So I am flummoxed as to how to get a tape signal the way that it was wired up. I might just try, well, the pin 8's, do we need to go through an inverter?
So I know we need to go through a capacitor, so that's what these are here for, but I don't see how these are connected up. Let me have a look at the underside again.
Oh my God. All right, so if we look at it this way, so the input comes to the capacitor, fair enough, and the capacitor comes down here, and then it is actually connected. There's just a whole lot of flux there. If I go in this way, I can confirm that, yep, so capacitor then goes to this base of resistors here. Right, so one of the resistors goes to pin 1, which is an input, and then comes out at pin 2. So it comes out at pin 2 back into here, back into this resistor pack sort of thing. There's a broken track there. So if I was following, like if it was a chain of inverters, right? Input 1, output 2, and then connected to input 3, output 4. The problem is output 5 is then connected to input 6, which is grounded. Five, 6, that's 7, 6, 5. So output 6 is grounded. Output for 6 is 5. 5 is connected to the, so 5 is the input, is connected to the output of 4. The output of 4, so it comes from the input of 3, which is here. But then again, all right, so we've got a chain of inverters, but the output is ultimately grounded. So again, how does this tape in supposed to fucking work? It doesn't make any sense. Unless this is just wrong. The machine's obviously been used. So unless it had been used and then they've replaced it with his new board and then, oh, we can't load any tapes. Maybe that's the problem, because the board looks pretty good. It looks quite new compared to the machine. So I think there's an error. There's an error here somewhere. Well, this is all a mess. And you can see there's deliberately cut tracks and stuff, but ultimately all the outputs are grounded, so there's nothing going to the tape in on the BMK. So it doesn't matter what signal I put in, it's just being brought down to ground. I'm just dumping it into the ground plane, I guess. What do you guys think? Does that make sense? Because I can't. Like, I have tried putting the signal in here and nothing. I can't pick anything up on the tape in port. So I think this is the problem. There's something wrong here. I should probably just rip it all out. I'll show you the picture of the underneath. Rip it all out, and then maybe just do something, what they've got on a proper Sinclair. Pretty simple. A couple of resistors, a couple of capacitors, and we've got diode, but I know the BMK works differently to the ULA, because the BMK does a lot more than the ULA does. So on the actual Spectrum, we've got cassette speaker shared on the same pin on the ULA, whereas we've got separate sound tape in and tape out pins on the BMK. So that's why it's taken me a few days, because I've just been going around in circles with this shit. Let me know what you think. Thanks for your help as always. Bye for now. Aha, before you go, I thought I should show you on the oscilloscope what signals are around the various parts. So I've moved the tape input from the computer back to where it was originally. So input to the capacitor. So I'll show the image, the waveform coming into there, then the output from there, and then I guess, so this is the tape in signal, so I guess there as well, and I guess the input to that, the pin 10 8, 9, 10. So input to 10. Yeah, so I'll just show those. See what you think of it. Okay, machine's up and running. I've got load done. I'm trying to load, I've got WAV file for Jetpack in Audacity. Press play. So I'll show you the input signal on the, so from the computer. Okay, press play. Alright, first header, first, second. Alright, so a gap, some more data. So it's pretty low. I could probably increase the volume. I've got the volume at 79%. As you can see, I'm increasing the volume, decreasing the volume. Doesn't really matter anyway, we'll see. Alright, so that's coming out of the computer. This is the other side of that capacitor. As we expected, we've basically got rid of the DC. And the signal's gone off floating to La La Land. so we've got that's the other side of the capacitor. So but yeah, you can see basically we removed the DC. Okay. What about pin 1? So this is pin 1 of the inverter. That's one of those resistors. Sorry, I keep slipping. Pin 2 is an output. So I keep slipping now. That's pin 3. That's pin 4. Why am I slipping now all of a sudden? 1, 2, 3. So that's pin 4. Let's just do auto again. So it's like almost TTL levels. Well, it would be, I guess, output from the inverter. Alright, oh, look at that, nice and square. So that's pin 4. Hang on, let me keep up. Where's the diagram? So pin 1 was input, pin 2 was output. So this is, alright, let's start again. Pin 1, fuck's sake, man. Pin 1, that's an input. This is the output of pin 1. Okay, that's pin 2. Pin 3, which is an input. Alright, and then pin 4, which is the output. So that's looking, wow, look at that. Nice square waves there. Pin 4 is an output. Pin 5, which is an input. Look there. Okay. Pin 5, pin 6, which is an output of pin 5. But pin 6 is grounded. So pin 5 input to pin 5 is that, but then pin 6 is grounded. So okay, we get nothing. Pin 7's ground. We come around to the other side, we've got pin 8. Pin 8, which is an output, which is output to pin 9. And pin 9's grounded, so that's what we expect. It's just high all the time. Alright, pin 9, which is grounded. Pin 10, which is the input to the BMK. Nada. Nothing. Grounded. So that's pin 10. Pin 8, pin 9, pin 10. Alright, pin 11, which I think we were expecting as well. So pin 11's an input. Yeah, so pin 11's input for pin 10 output, which goes to the BMK. And pin 11 is fed by pin 8, which is grounded. So there are some, these are the other, and that's just VCC. So that it does look like there is some good signals once they get processed, inverted in, we get some very nice square waves, but none of these are used. Well, that looks like a very good signal. Why can't I feed that into... I don't understand it. 1, 2, 3, 4, 5. So that's pin 5, which is an input. And pin 6 is the output, which is grounded. So pin 4 then. What about if I take pin 4 output? What if I take pin 4 output and then feed it straight into the BMK then? Oh, hang on, what's going on there? Oh, we've stopped playing. 1, 2, 3. 1, 2, 3, 4. Let's go back to pin 4. 1, 2, 3, 4. Pin 4. Let's press play again on the computer. Why don't I feed that into the BMK? That looks nice, doesn't it? Solid, I might do that. Pin 4. Pin 4 is output from pin 3. Alright. Maybe we've solved it. I don't know. Let me do that because it's funny. It's 10:30 at night. I'm sweating. I just want to go to bed. Maybe do this tomorrow. You guys tell me if I'm on the right track. But it's just a matter. Let's have a look. So I think I've powered it off. So at the moment, we've got this little wire that's taking the input to the BMK. So I should just maybe move that wire 1, 2, 3, to pin 4. That might make more sense. You can see pin 4 actually did go somewhere, probably on the underside of the board. You can see there's a hole there for a wire, but you can see that it's actually been scratched, so it goes nowhere. Fuck it, I'm gonna move this wire. I don't know why the fuck it's wired like that. It doesn't make any fucking sense. Right, I've moved it to pin 4, so that should be feeding the BMK. Tape in. Let's start recording. Now load. Okay. Oh, now that's different. That wasn't happening before. Press play. Magic. How fucking bizarre. So I reckon they've replaced the original board and then put this new board in and messed up the tape-in wiring, and it's never worked. I don't see how it could have worked. Possibly worked. I don't know if this is actually properly loading or if I've got the volume too high. Might put the level a bit down to 65%. Alright, let's stop and start playing again. There we go. Okay, so that's at 65% output. That's another block. Okay. Another block. And then here comes a big block. Okay. Might still be a bit flaky. I don't know. Do we get a loading screen on Jetpack? I don't know. Well, we were never getting the flashing, what is it, cyan and red before. I guess because, well, I don't know why, because it was held low? Or what was the output held high? I'm not sure anyway. Alright, it's coming to the end of this first block. So this is a WAV file converted from TZX, using main CAS tool. So I'm not sure if it works fully. All right, let's see. I think we're coming to the end. There's a couple of small little blocks. And one small one. and then there's a gap, and then it looks like it's the same as what we had before. So okay, I don't think that's loaded properly. It doesn't like something, so I still might need to fiddle with it a bit more, but it's working better than bloody. Oh, okay, hang on. Oh, this seems to be like maybe this second block. I don't know. Anyway, it's late. I think we're making progress. Thanks for sticking around. Part 3, I'll definitely have something loaded, and I'll figure out why this audio output isn't working. Okay. Bye for now.